So we're going to look at slopes of parallel lines and also perpendicular lines. So parallel lines are basically when we have two lines that go at the same angle. So we can describe them as one, when the two lines have the same distance between them, or the two lines never meet, or two lines with the same slope. Perpendicular lines we describe as two lines that meet at 90 degrees, and we're going to come up with another definition for that. So here I've drawn for you these four lines based on this table of values. And just visually looking at these lines, we can kind of see that the red line and the blue line, they look parallel. The green line looks kind of out of whack. You can see that it's not quite parallel with the red and blue. And this green line here is perpendicular. It doesn't look like it's perpendicular to the purple line, but it's definitely perpendicular to the red line and the blue line. Okay, so I'm just going to draw in that 90 degrees to show the perpendicular nature of these two lines and these two lines here. They are 90 degrees. Okay, so we can visually compare that that red and blue are parallel. We can also calculate the actual slope values. So if I draw a little triangle in here, I can see that my rise is +2, +1. Okay, I can compare, so the slope equals +2/1. Okay, I can do the same for the blue lines here. I can just choose any 2 points. In this case here there's a +6, +3. So the slope of the blue lines is going to be equal to +6 over +3, which simplifies to 2 to 1. Okay, so we can see that these are parallel lines. So the blue line and the red line are parallel, and we show this with these two arrows. They're parallel lines. Looking at the green, let's do the purple first maybe. Taking a look at that purple line. Okay, so the purple line will calculate the slope here as well. Now it almost looks parallel, but when we actually calculate the slope, it looks like it's +5, +2. So the slope of this line, I'm just going to write it up here, so slope is equal to +5 over +2. So that's going to be 2.5. So it's not quite the same as 2 to 1, it's 2.5 to 1. Okay, so this is a little bit steeper, so this is not parallel. So parallel lines, they're the same distance apart. So if I count the squares along here, 1, 2, 3, 4, 5, between red and blue, 1, 2, 3, 4, 5, it's consistently 5 lines apart horizontally. We can count the same distance vertically. It's going to be consistently, it looks like here, 1, 2, 3, 4, 4. And then between any 2 points on the blue, between the blue, not 4, sorry. If I count the distance between the blue and the red vertically, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and if I find any other 2 points, so vertically here between that point and this point here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it fits both definitions, the same slope. Okay, the same distance between them, okay, and they stay consistently the same distance, and the red and blue lines never meet. So looking at the perpendicular lines, we can see that the red and blue lines are perpendicular to the green. So how do they make a 90-degree angle? Well, what about the slopes? How do the slopes compare? So let's draw in our slope triangle here, and then take a look at our slope. So it looks like left to right it's going down 2 and over 4. So slope of this green line is equal to -2 compared to +4, or -1 to 2. So how does that slope compare to the blue line? This is +1 to 2. This is -1 to 2. So there looks to be some sort of connection here. What's happening to the vertical? It looks like it's happening to becomes now the horizontal. So this vertical ratio of 2, or sorry, the vertical ratio of 2 on the blue line, so this 6 parts here to 2 parts. Now it looks like the triangle is going to be rearranged horizontally, so it's kind of being rearranged horizontally to the long side 2 to 1 ratio is now horizontal to vertical instead of vertical to horizontal. The other thing that we should notice is that the slope for the blue line is positive, but the slope for the green line is negative. So these are some ways that we can start looking at perpendicular lines. We can kind of start saying, well, the perpendicular lines meet at 90 degrees, but we can also say that the slopes change. So for the original line, if the slope is a to b, the perpendicular line, it looks like we're flipping this around to negative b to a. It looks like the vertical becomes horizontal and the horizontal becomes vertical, and some negatives falling in there at somehow. Okay, and this is actually a property of 90 degrees in the coordinate plane. We can see that we're going to shift our vertical triangle here, the vertical part of the triangle shifts to the horizontal, and the horizontal here shifts to the vertical. So x's and y's switch, but it's not just a switch. They're also going from positive slope to negative slope.